All right, let's go ahead and start video 10B. The objective for today, we're going to understand how ramps help us out. The agenda, there's going to be it's all uphill activity. We're going to introduce ramps and just check the introductory video for all those announcements on those homework assignments. Big question for today is, why do mountain roads twist and turn around the mountain? Why not take a more direct route up? So there are codes and videos. There are two codes in each of the three videos. One will be written and one will be verbal, said by myself. Each code will be three numbers. You'll need the codes in order to move on with the assignment. Now, when you're taking notes, just write what it's in green. Now, this is the video 10B written code. It's 522. So again, the 10B written code is 522. So we're going to start this day with the It's All Uphill simulation. Now that leads us into the why does Ben Davis have stairs instead of a ladder? So that brings us to ramps, right? So if you're looking at this, which card has the largest force applied to it, raised up to it? You can see it's the one on the right, the one at the steepest angle. Which cart traveled the longest displacement to raise up the height? So it's going to be that 30 degrees. Let's see. And which card had the largest amount of work exerted on it in order to raise it up the height? So they're all going to be the same. Notice that the work is going to be the same when it's at the top of the hill because it's the same cart. And remember, they're going up against gravity, but gravity is conservative. So each of them did 8.822 joules of gravitational potential energy, right? So if you were pulling a cart up, how steep would you want the ramp to be? And you'd want it to be pretty shallow because you can see here the force is going to be different. You want to apply a shorter force to pull something up. So would the ramp affect the amount of work done on the car? So no, it doesn't. It doesn't affect the end result, but it does affect the amount of force that you would have to apply for a longer period of time or a longer distance. So I like to think of it as this way. I don't want all this force. I don't want to apply all this force. I'm going to give some of that up, and I'm going to have to apply that smaller force for a larger distance. So why do mountain roads twist and turn around the mountain? Why not take a more direct route? It's because it's a longer distance up to the same height. So what it's doing is you're trading in some of that force that you wouldn't want to do. You couldn't drive a car straight up. It wouldn't work, right? You need shallower, but you're going to have to go a longer distance in order to get that same gravitational potential energy. So at this time, this is the 10B verbal code is 122. I say that again, the verbal code is 122. There are the links for the day. And as final thoughts, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.